Hi everyone, I'm Michael George and I'm going to talk about macOS host monitoring and how you can do effective incident response using lightweight open source tools. So, a little bit about myself. My name is Michael George. I'm a security engineer at Dropbox. I primarily work on incident response. You can find me on Twitter and GitHub with the username PikminSec. And I'm a huge fan of Tachikomas, which are these like multi-legged spider bots from Ghost in the Shell. You'll find them everywhere. They're great. Alright, so the first thing so what I want to talk about today, I would like to go over an incident, an example incident, and what we need to be able to do to respond to such an incident, what vendors can do to help us respond to these incidents, and what features they have, and what we can do without vendors. And I'm going to cover a couple open source tools to help me do that, including OS Query, Santa, and Audit. So first things first, incidents happen, compromises happen, people get their laptops infected with malware, and you have to figure out exactly what happened on those machines. So in a macOS heavy environment, this may be difficult to do. There are not very many tools out there, and most of them aren't that mature. So does anyone recognize this application?
No.
No. So this is Handbrake. It's an open source tool to help you transcode video files into other formats. It's pretty popular. It was recently compromised and started distributing a piece of malware known as Proton. And we're going to use this piece of malware as our example for all the tools. So what do we need to do when this type of notice goes out? Well, first we need to figure out what hosts are infected by checking for known IOCs, like basically being able to scan our network to figure out who's infected. And then for each of hosts that is infected, we need to be able to establish a timeline, such as like when was the application installed, and then what did the malware do on the system, such as creating a process tree, like what network connections were made, what files were touched, what kind of stuff might be stolen, what other pivot points they might have. Just generally like figure out what exactly happened with that piece of malware. So, what can security products help me? Is there like a one-stop shop for all things security, especially in the OS X land? Well, kind of. There's a bunch of well-known EDR vendors. EDR stands for Endpoint Detection and Response. A lot of these vendors have features such as being able to create process trees, like nice visualizations for it, show you which network connections each of these processes made, a bunch of file monitoring, tell you like what files it made, any persistence mechanisms it added, well, in some cases give you the hash of the processes that have been executed, and then sometimes even the full upload of the file that was executed for every host. It's pretty awesome. And then also, it kind of acts like a SIM, so you should be able to query your whole fleet and figure out if like certain applications ran. Another thing that some do is allow you to do automated analysis of like network connections, the hashes, generally any IOCs from like these systems. They run it through like VirusTotal or something like that. But they're not all great. Well, they cost money for one, which sucks. No one really likes spending money. Another thing, a really common complaint in the community, especially for macOS, is kernel panics. Like they make the system unstable, and generally having your computer turn off like randomly every 15-20 minutes is not like a good use of engineers' time. And they can also be pretty burdensome on the machine. Some having like really large overhead, so if you're doing like compiling or rendering or something like that, they may slow down this process significantly, basically costing you large amounts of money. And then even after all of that, it's hard to like turn the knobs on them, like tune down some things to make it a little bit more effective or efficient on your machine. And we want to be able to like do all of this without having to rely on a vendor. So, what do we do when no one wants to solve the problem that we want solved? Well, we're hackers, we build it. That's like what we do. So, let's go back to the things that we need to do. We need to be able to identify infected hosts in our network by checking for known IOCs. So we're going to query the fleet. There's this nice tool called OS Query, developed by Facebook. It's basically SQL for the operating system. It has a bunch of tables in it that are populated, such as installed applications, currently running processes, cron jobs that are installed, services. There's a bunch of them. It's really great. And in order to interact with that, you can do scheduled queries. You can have like a query to the system on like every hour or 15 minutes or even every second if you really want to, and then give you the information from that system that way. You can also run queries in real time using some extra third-party tools such as Collide and Windmill. There's a bunch of other ones I just don't have time to list them all. But if you do that, it allows you to get these logs, and it does a diff. So it only takes a log if the event changed, essentially. So if you installed an application, you'll get a log for a new installed application, which keeps the log volume pretty small for you. So any of you that have log volume limitations, this is a pretty good tool for that. One of the other features that recently came out for this is they included OpenBSM logs, which is a really cool feature, and we'll be talking about that later. So if you were looking into this, you might not even need the audit section of this just to get those execution logs. So here's an example of what it looks like when you interact with it. It's actually just like a straight up query, like a SQL query. So from here, I'm selecting a file from a path and seeing whether or not it exists, and it returns some information about the file. In this case, it's actually activity agent, which is an indicator from the Proton malware, which is, like you can see, inside the file, render files, activity.agent. It's definitely running on my machine. Really bad. One of the other really awesome parts of OS Query is they include these packs, which are a bunch of default queries for you to run, which will give you a bunch of information about the systems in your network, such as installed applications, and installed applications, cron jobs, services running, new network connections, stuff like that. But you can also get this pack that is called OS Attacks, which has a bunch of indicators for new malware. It's constantly updated. So you can, even inside of the default OS X pack, you get an indicator for this Proton malware. So if you're running it, then if you got return logs from it, then you know you have Proton somewhere in your fleet, probably on the host that returned it. So that's really cool. It also includes other stuff such as techniques that people use, so trying to copy keychains and stuff like that. So it's just, you should do that if you end up using OS Query. All right, so what do we still need to be able to do here? So with OS Query, we were able to query the fleet and determine if a certain thing existed on the network or existed on some machine. The next part we need to be able to do is figure out exactly what that piece of malware did on the machine. So we need to be able to construct process trees and basically log network activity and what files it touched. So what we're going to do is we're going to use Santa. Santa is a syscall monitoring kernel extension that monitors all execution events. It also takes hashes of all the executed binaries and records the certificate hash for each of those binaries. So if you need to trace back all the things signed by a certain product, then you could do that. It also allows you to blacklist and whitelist the execution of processes. So you could say, I don't want to have iTerm running anywhere in our network, or I don't want to run Handbrake anywhere in our network. Or you could block all things and make a whitelist and say, we're only going to allow approved software on our machine. It also contains a signed kernel extension. If you know anything about this is OS X blocks all non-signed kernel extensions. So Google is nice enough to package this up for you so you don't have to compile it and sign it with your own, which are actually kind of difficult to get a hold of. So here's an example of Santa. From this, we can actually see it's a move command for part of the activity agent.app trying to install persistence on my machine. So it moves a malicious plist into one of my launch agent folders. This is so I can continue connecting with the malicious C2 server. The next thing, the second part, is it actually exfilling a bunch of my private data, including I'll go over that later, but it includes a proton.zip, and that's what it's posting up to this website called handbrake.biz. It also includes information such as my username and my password, whether or not it's the root password, my serial number, my host name. This is actually all really good information to have if you're trying to investigate an incident like this. So even more process execs. So this is an example of it zipping up and stealing my 1Password vault, which sucks. But yeah, it is. I mean, the other stuff that it will steal, your Safari like login sessions or cookies, your for all the browsers really, but like your passwords, sessions, cookies. There's another one, form data. If you guys are familiar with that, it's all a bunch of really good ideas for where to look for badness. Is anything touching those folders? It'll also try to steal your keychain files, which can include your like internal certificates and your SSH keys, depending on how you like have it installed on your system. But it also, in this like process chain, it also tried to kill some analysis tools such as Wireshark and Console. So if you were running in a sandbox, it was like trying to disable some sandbox like activities. So that was pretty cool. So I mean, that was just from like looking at the Santa logs from the execution of this malware. So it's almost like we have every machine being like a sandbox for us, such as like Cuckoo, but it's super cool. Another thing that's really cool about this is the hashes. If you had such a system where you could, check against a threat intelligence vendor like the hashes in your network, then you could, in theory, like do a threat intelligence lookup every single time a process executed on your network. So in this case, if you were to look up this hash in some sort of like threat intel vendor, you would get like, it has a detection rate of 23 out of 54 for certain types of antivirus engines, which means like, yeah, it's probably bad. And it's in the scary red font. Another thing that it's really cool about Santa is it includes a quarantine URL. So a little known feature, if you actually like look into the data structure of like files on the files on the hard drive, you can see where it was downloaded from, especially if it was downloaded from the internet. It works for HTTPS as well. So you can see on this, it actually is downloaded from like a local server I set up just so I could transfer the malware to the system. But if it was downloaded from the internet, this would help you like try to figure out attack vectors for how the actual malware got on your machine. If you were running it like Office 365, it might be cached somewhere, and so you see it downloaded from like a CDN somewhere, and then that would help you like realize, oh, maybe this came from like email or something. So this can be very useful. Also, process trees are rad. This is a malicious Word doc. We can actually see everything that my malicious Word doc does on the system. It does a curl request to some hosting site to download a PYC, then it executes it, and the process of the newly downloaded and executed process writes another file to the /temp folder for fresh cert, probably doing some sort of like encrypted tunneling out of your machine. So that's pretty cool. Like we can just create a big process chain of like anything that happens like every time for any piece. It's great. But Santa isn't enough. Santa, as you noticed, didn't include a lot of the network signatures. Like it did for some command line stuff. It didn't really tell you much about files it was like modifying, especially if it happened inside the binary, except for in that last one where I showed you. That's because of the next part. So because we can't get all that information out of Santa, we have to use another system. The other system we're going to use is Audit. Audit is built into all of the OS X systems, like into the kernel. It's kind of a pain to set up, but it allows you to watch basically every single type of syscall from the operating system, such as like network calls, file opens, file like reads, create events, everything, like just binary load, like just everything that you want from this. It's kind of a pain to set up, so I included a section on like how to set it up a little bit, just so you can get a good idea of like how difficult it might be in your environment. Yeah, the picture is because it's kind of pain. Like, trust me, this isn't as easy as I would like it to be. But so for everyone that's here, if you modify the audit control file in your Etsy security audit control, change the flags up to what you would like to monitor for. Some examples I included in here are NT, FC, FW, and AA. NT is the network connections class, so any type of network connection. FC and FW are file writes and file create events, and the AA is administrative activities, so you can see like the root user doing stuff. It's kind of good to have. Then after you set all that up, you have to run audit again, refresh everything, just get it running, and now it will write all of this content to the dev audit pipe. So if you read from that pipe, you will get all the syslog data in binary format, or sorry, all the system data in binary format which sucks because you can't do anything with it. You can't read it. So you need to then pipe that to another tool that's on the machine called Audit Reduce that will convert it into something readable, such as XML or syslog. All right, so here's an example of like what it looks like after you get all the data from your system. Sorry, after you get all the audit data off and you get it converted into XML. This is a file open event where from the piece of malware, it opened up and wrote to a file called GNU_PW. This is where it stored my GPG keys before it tried to upload it out. So this all goes into that proton.zip. You'll see a similar event for every single one of the other like exfil style events in here, such as it stealing your keychain keys and your Safari like login tokens. It all zips it up into a file and then sends it off. The second event is a connect event. This is the connection from that curl where it sends it up to the C2 server using for exfil. You notice here it doesn't actually have an IP address. It has something called var run DNS responder. This is because all network connections, if they have a domain, go through a DNS-like resolution system called MDNS responder. So if you want to get the domains out of this, you actually have to go to another service and get the domains out. So I included that for you. So here's what so this is the log format, the syslog format for MDNS responder. I included a command line at the bottom for you if you want to get your OSPRIV logs back and your MDNS responder logs back. A couple versions ago, they removed all of OSPRIV and MDNS responder logs from the system. So if you got past the Sierra upgrade, you probably don't have those logs anymore, and they didn't really tell you how to get them back. This is how you get them back. And you can also use this to link back to the process ID. Everything is still tied to the process ID here. So other examples for useful alerting using Santa, the audit, and the OS query. So for those of you that have used Empire before, this is a example piece from one of the stagers. This actually checks for little snitch running on your system. If you were to just run this on your machine, then you would get this really nice piece of code out that says, "Oh, look, I'm looking for a little snitch." And if you basically look for that in your network, then you could possibly say that this is Empire running on your system. So that's basically translating post-exploitation toolkits into real alerts, using real logs. So hopefully, after showing you each of these tools, I can say that you can identify infected hosts by checking for known ISCs using OS query. You can either use the query packs or you can create your own if you read a notice online. The next thing would be for each host in your network, you want to be able to create a timeline, which you can either use OS query to figure out when the application was installed using the logs, or you can use Santa see when it was executed. But those aren't necessarily the same thing. Then you need to be able to figure out what the malware did, and using audit and Santa, you can get a pretty good idea of everything that a piece of malware did on your system, down to the file writes, the file creates, file opens, and the network connections that it made. So what's next? So recently, OSQuery added support for OpenBSM logging, so you actually may not need to go through any of the OpenBSM setup for this. You can just basically start up audit on the system and use OS query to read from it, and it will parse out all the logs appropriately for you. So you don't have to set that up, which would be really good. Adding better DNS support and audit. So you know how said MDNS responder instead of the actual domain, since we know that's returning back to the system, you can actually just loop that in yourself, or you can ask the OpenBSM community to put it in for you, since it's already going back there anyway. And then getting lists of modules loaded for binaries during execution. I'm pretty sure you can actually do this using audit, but I haven't been able to get it to work appropriately, being able to link up all the binaries that were loaded to the system, but I think you can do it using OpenBSM. I just haven't been able to get it to work yet. So I hope that by explaining all this, that you should be able to use OS query, Santa, and audit to perform lightweight, free, extensible incident response. All of these are open source. So if you need to add, or if you want to add features to any of them, they're pretty easy. Most of the communities are like really nice. I'm like really good friends with the people who run OS Query and Santa, and they are like really open to ideas and suggestions. So if you have like any ideas such as like blocking execution events based on quarantine URL or something like that, they're really open to like talking about these ideas. All right. Well, thank you for your time. Do you guys have any questions?
OS Query, is that just the client side piece?
Yes.
What are you using for server side to
manage? So we're using a SIM. We're basically forwarding all our logs to a central log aggregator, but it does include in the client piece a TLS forwarder. So if you have like some others, like just generally like syslog aggregator or something like that, you can just forward your logs to that. But you should definitely like have some sort of central logging if you want to use these tools.
But you don't have an ability to query all your endpoints for like, hey, has anybody seen this?
Oh, that was what I was talking about with Collide and Windmill.
Mm-hmm.
Those allow you to do real-time like queries. So you basically have all your systems like hook up to it,
mm-hmm.
and it pushes a query down to the host that you want to run, and then returns the results to you. So there's definitely a way to do it, and like people are like banking on that. So,
okay.
Any other questions?
In terms of getting it on the endpoint, like deployment,
Mm-hmm.
because that's the thing. Like that's sort of the catch, and especially like in an enterprise environment. If you're dealing with Mac, the weirdness there, especially if it's a handful of boxes, but they might be really valuable boxes in a certain sense because of whose they are or whatever.
Yeah.
You can't just. Well, I mean, you can't. With a lot of Windows things, you're just going to deploy something through like a GPO.
Yeah.
But this, like, how at scale? Like, right? I understand on an individual box.
So
you can follow these steps to configure stuff, but like. What is your approach as far as like for your organization, like deploying it at scale?
There's a couple options for config management in OS X, such as you can use like either some MDM like Jamf, or you can use like Puppet or Chef to like push configs out to these boxes. These are just like PKGs. Like you can just basically execute them on the host, and they work pretty much right out of the box. Like Santa will just start up in monitor mode and start logging to the appropriate location. OS Query will start running whatever's in the default pack, so start in the default config. Audit, you will probably need to write your own custom like launch daemon for this, which is what we ended up doing. Like we have a launch daemon that like runs the audit commands and basically runs them through a filter and then outputs the results. So I would suggest that something like that for audit. We might be able to open source this at some point, but I don't know about that. But for everything else, it's like pretty easy. And for OS Query is implementing that particular section in OS Query, so you should just be able to get these logs like from there versus having to set up your own launch agent or launch daemon to do this. So for that, it should be a lot easier going forward. Any other questions? All right. Well, thank you.